Test.
Josh?
Hello. Aloha. Can you hear me in the back? Thank you.
Okay. Dr. Tom Dye received his bachelor's degree here, University of Hawaii at Manoa in anthropology, and his master's and PhD also in anthropology from Yale University. He has dozens of publications and a recent book on Hawaiian archaeology. His interests are in carbon-14 dating, examining fish remains, his clues to the past, and statistics. His current position is president of TS Dye and Colleagues, Archaeologists, Inc., Honolulu, and he's also affiliate graduate faculty here and an instructor here at University of Hawaii at Manoa in archaeology. So please join me in welcoming here today, Dr. Dye.
Aloha. Cindy's asked me to come talk to you about, can you hear me in the back? Test.
No, it's the button in the...
Test.
Yay.
Hey, thank you very much. It takes a village sometimes. Cindy's asked me to come talk to you about the influence of Polynesians on Hawaiian natural history, and that's what I intend to do today. Outline of the talk, I'm really going to focus on two things. First is the time aspect, because the longer people are here, the more time they have an influence on the natural history of the islands. And also the space aspect, because if people are in a small area, they have less effect than obviously if they're settled over a larger area. And so I'm going to start off with the question of when Polynesians discovered and settled Hawaii. A little bit about settlement as a process, because we often think that once the islands were discovered, they were settled, but that does not appear to be the case. We'll look at the kinds of plants and animals that Polynesians introduced, and then, like settlement, that was also a process, and we've found two waves of introductions, which I'll describe as the first Polynesian introductions and then the subsequent transported landscapes. Then I'm going to look at the end about agricultural innovation and expansion. This is the spatial part of the talk, and then I'll focus on the leeward Kohala field system, which is one of the most incredible archaeological sites in the world, and shows the spatial extent of Polynesian effect here very well, I think. Okay, we're okay?
Just leave it alone, you're good.
Okay. The way I've structured this is I'll give you an outline so you can have something for notes, and Dr. Hunter is going to have this available for you on Laulima, so that you can download the PDF, so you really don't have to take notes unless you hear something that I haven't included in the notes here. But in this section of the talk, I'm going to point out that archaeologists have been clueless for a long time about when Polynesians discovered and settled the islands. And that's important in case you do any research of your own. You're bound to run across an estimate that's just dead wrong. And so I want to correct that from the very beginning. Last 2 decades, these guesses have ranged from the time of Christ to the 13th century AD, which is a huge, long range. But the best estimate today is about 1000 to 1100 AD. This is a graph that shows you the historical progression of estimates, and what you can see here, oops, wrong button. The settlement estimate is here, so here is the time of Christ. We move up to about 1000 AD here, and this is the 1 and 2 standard deviation. This gray line here is the 1 and 2 standard deviation estimate that we now believe to be correct. And so what you can see here is that beginning from, this is when radiocarbon dating was invented in 1950. Basically any kind of organic matter that is buried in an archaeological site stops taking, it's dead, as soon as it dies, it stops taking up carbon from the atmosphere, from the ocean, and the carbon-14 that's part of every thing that has carbon in it decays with a half-life of about 7,200 years. And so you can measure the carbon in a piece of organic matter or charcoal from an archaeological site and determine how old it is. Traditions and analysis of traditions seem to indicate that the Polynesians got here about AD 1000. There are several analyses of traditions. This depends on how long you think a generation is and how much you believe that the genealogies go back to the first settlement time. So I put this in here just for reference. But what you can see is that from the beginning of radiocarbon dating up through about 1985, archaeologists were racing to have the oldest date that they could find. And every time somebody would come out with an older date, it was seen as a great success for archaeology because we've managed to push this thing farther back into the past. That changed in the early 90s with a couple of archaeologists, one from New Zealand, one from Australia, who put the kibosh on that and came up with this estimate here. We followed with a period of about 20 years up until very recently when there was an argument for a long chronology versus a short chronology without much new data. And then finally, we've now settled up here for the time that Polynesians discovered Hawaii. Now, the way that we do that is primarily through something called paleo-environmental coring. I don't know if you covered that in the class, but it involves taking a machine to bore down through, usually in a wetland where sediment accumulates and does not erode away, so you have a continuous record of deposition. The core bores down through there, and then you pull up this core as a long tube of sediment that has not been mixed up. And you break open the core then, and you're able to look at the sediment back down through time. And this is important because it goes back before the period that Polynesians were here. Okay, so we're able to find organic matter, usually pieces of twigs or seeds or leaves in these cores from before the time the Polynesians were here. And then we have lots of dates from our archaeological sites of when Polynesians were here. And what we do is we calibrate them according to standard procedures, and we see where they meet, these two curves of the pre-human dates and the post-colonization dates. And if you look just using plants, what you find is this is an estimate here, and if you also include rat bones, which were an early introduction, dates on rat bones, then you get actually a much tighter estimate, around 1,000 to 1,100. The nice thing about this is instead of having that situation where people are arguing back and forth, is that as you add new data, your estimate gets better. And so what you can see here is the first time we tried this, we didn't get very good results. There's a wide dispersion, and the center peak is not very high. But adding quite a bit of new data over a period of 3 years, and this mostly involved going back through contract archaeology reports and pulling out data that I hadn't found in 2011, your estimate gets much better. And the central tendency doesn't move very much. So it gives us some confidence that we're on to the right answer now. Okay, now let's think of settlement as a process. If you go back in the literature, archaeological literature, and read, you'll find that people don't talk about this very much. It's as if the Polynesians got here and that was it. End of story, they settled the place. Okay? But the settlement of Hawaii, we now know, was a very difficult process. The voyage of Hokulea showed that it takes about 30 days or so to sail from the homeland down in Tahiti, the islands of Marquesas, up to Hawaii. And it takes another 30 days to sail back. What this means is that the people who took off in search of new lands from the Society Islands and the Marquesas, that area of the eastern Polynesia, were prepared to be at sea for 60 days. Now think of that, okay? If I told you that I was going to go out to sea for 60 days on a boat that I had built myself, would you come with me? No, I wouldn't either. I wouldn't go with you guys. No offense. But my point, being a little flip, but my point is that these folks were doing things that nobody else in the world was doing. Hawaii is the most isolated landmass in the world, and it was one of the last places on Earth that modern humans got to. Okay? So this was an achievement, monumental proportions. And when the Polynesians did it, my ancestors in Ireland were afraid to sail out of the sight of land. Okay? The point of this, question?
Just wondering, did these Polynesians in these islands, did they by any chance like have maritime trade with each other if they had ships capable of going from these islands to traveling these long voyages?
Absolutely. I don't go into the whole story of Polynesian settlement and discovery, but it starts in Southeast Asia about 3,500 years ago. And it has various pulses to get up here. But if you look at the geography of the Pacific from Southeast Asia out, mostly south of the equator and then north, Hawaii is by far the most isolated place. So the voyage was much, much longer than any other voyage the Polynesian people had undertaken at that time. Answer your question?
No, I was saying, did they engage like in maritime trade with these other Pacific Island groups if they had boats capable of traveling these long distances?
Yes. The answer to that is yes. There was trade. So the settlement process here was likely multi-generational. People discovered the place, went back to the homeland, and then came back and forth, until the islands were fully settled. Okay, let's look at the first Polynesian introductions. The Polynesians introduced about 30 useful plants to Hawaii. This is out of a total of probably 50 introductions to Central East Polynesian. 30 of those made it up here. Farther back along the route, the number goes up. It's like 60 plants in West Polynesia, and more as you go farther west. But about 30 of those made it all the way to Hawaii. Polynesians introduced pigs, dogs, chickens, and rats. Okay, now first things to be introduced were rats and kukui trees, and these rats had a really major effect on Hawaiian natural history. And this is probably the first major impact that we see from Polynesian people. Large flightless birds, which you probably learned about in the class. These went extinct almost immediately because they could not compete with the rats for food. We'll see that these dominant forest trees and shrubs, the lowlands area like Manoa here, the fantail palm or loulu was very, very common. In fact, we think of much of the lowland forest before Polynesians was dominated by loulu palms. This shrub, Kanaloa kaholavensis, was unknown to science until it was discovered two or three individuals on a sea stack off of Kaho'olawe Island, based partly on the fact that the pollen from this in the paleoenvironmental course was unidentified. But it was very, very common, and people wanted to figure out what it was. Once these two or three individuals were found on the sea stack off of Kaho'olawe, fortunately they were in flower. Somebody grabbed one of the flowers, shook a little pollen off of it, and bingo, made a match to this pollen that was very, very common in pre-Polynesian times in the cores. And the last one that was almost went extinct was the a'ali'i, very, very common in the forest. Now, part of the story is that if you're going to do farming, lo'ulu palms are not something you really want to clear. They're big, they're tough, and it would have been tough to clear gardens out of the forest if it's full of lo'ulu. And so the forest gets softened when the fantail palm starts to decline, probably because the rats were eating its seeds. Rats love lo'ulu seeds. People can eat them as well. They're not so great. But the rats like them a lot, and the rats probably made it impossible for the lo'ulu trees to reproduce in their natural environment. And this softened up a forest that was really going to be a tough job for the gardeners. Okay, now, having said all this, we have almost no evidence of cultural activity during the first few centuries after Polynesian discovery, okay, which is part of the reason that we were really talking about a multi-generational process. It doesn't look like there were that many people here for the first couple hundred years after the islands were discovered. This is going to be hard for you to see, but this is the pollen record from the Paleoenvironmental Corps. This is the best one we've got. It was taken at Ordi Pond, which is out on the Ewa Plain here on Oahu. It's out at used to be Harbor's Point Naval Air Station. It's now been set aside as a cultural site. A couple months ago, it got preserved in perpetuity, according to the government, because it's the best place to find out what's happened to Hawaii's environment going back before the time of Polynesians. And on this diagram, we have zone A, B, C1, and C2. C1 and C2 are the historic period, B is the Polynesian period, and A is the pre-human period. And the big thing about the distinction between the pre-human and the human period is that there is absolutely no charcoal in this A part of the core, the deep part of the core, because there are no natural sources of fire here in the northern Hawaiian Islands, the older Hawaiian Islands. You go down to the Big Island where it's volcanically active, lava starts fires, there's no problem with fires down there, but we haven't had any volcanic activity in the recent past. So there's no natural fires here, and we don't see any charcoal down at the base of these cores. Charcoal starts here. It's because humans came and started to make fires. They burned off land so they could garden, and they cooked. And we see that in these cores, and so this is the reason that we know that this is where the Polynesian period starts. The other thing that you can see is when rats are introduced here at the same time, this shows trees and shrubs as a proportion of the pollen rain. Trees and shrubs are very, very dominant here, and you can see them decline and be replaced by grasses, basically. And this is likely a result of the rats, influence of the rats on the environment. Okay, this is the other side of that same pollen core. Again, A, B, C, and C, C1 and C2. And you can see here how quickly, this is the lo'ulu palm, how it's a dominant tree in the pre-human part of the core, and it falls off almost to nothing down here as soon as the rat is introduced. This one here is the Kanaloa kaholavensis, the one that was found on the sea stack off of Kohala. That one dives down. This one was almost extinct when it was found. And then this one is a'ali'i. You can see the same thing happens to it, a little bit slower. Question?
So what's the dominant tree right now? Just wondering.
On the lowlands?
Is that what this chart is for, the lowlands only?
This is it's taken from Ordi Pond, which is out by Harbor's Point Naval Air Station, Kalailoa district. You know that area?
I might have heard of it.
Yeah, it's a lowland area. It's a lowland area. The dominant tree out there today is kiave, which is an introduced tree.
Oh, so that's that dark one on the top right there.
This is it. This is Kiave here. And so you can see it introduced in the historic period and then becoming dominant nowadays. Good question, thank you. Other questions? Am I going too fast? Okay. Having looked at that, let's look at the second wave of introductions. First wave, the most important things were the rat and the kukui nut. The second wave of introductions came a couple or 3 centuries after Polynesian discovery. They include breadfruit, ulu, ki, which is the tea plant, the gourd or ipu, and sweet potato, uala. We finally start to get some archaeological information. But what I want to do with this is to show you some research that we've done over the years that indicates when that landscape, this transported landscape from the homeland, began to dominate the landscape here. Okay? When you had to switch over from native trees to Polynesian introductions. And most of this comes from the coastal plain of Waimanalo here on Oahu, the windward side. Excuse me. And we have 4 archaeological sites that we've worked at, and a 5th one which is very famous in the archaeological literature called 018, or the Bellows Dune site. It's often been thought of as one of the founding period sites. I think that's not true, but it is an early site, and it's part of a larger series of sites here on the coastal plain. Now, what I'm going to try to show you is distinguish these. Let me go to the next. I'm going to distinguish this northern part of the plain here from the central one, which is right around Puha Stream. It's now called Waimanalo Stream, but its original name was Puha Stream. This is the stream that comes out. If you go to Bellows, this is where the guard shack is, the interior guard shack, not the one by the road. Okay. So if we look up north here, these are the fire pits that we've sampled. Their locations up at the north here, and each fire pit has this symbol attached to it, and this shows the distribution of how, Hibiscus tiliaceus. And what we see here is that how is absent from all of these here, and one is present. It's very rare up in the north. And when we go down south and we get near Puha Stream, which is where the how likes to be near the stream, what we find is that it's a very common part of the firewood that we dig out of these fire pits. So we like this. It says Waimanalo Stream here. I should say Puha Stream. We like this because we have a very, very spatially restricted sample from each of these fire pits. People are not taking firewood from the stream and marching it 10, 15 minutes walk north for fire pits there. The firewood is coming from the direct environment right around the fire pit. Okay, so what we can do then is if we take the radiocarbon age, and this is approximately 100 years ago, back to approximately 700 years ago, and we look at the firewood, we can actually tell what kind of plant each piece of charcoal came from. We take the charcoal out of the fire pit with our archaeological excavation, we send it to the specialist. The specialist divides it up into different kinds of plants, and it counts how many pieces of charcoal are from each plant, from each fire pit. If we look at them, and then we date each fire pit, so we know how old each assemblage is. If we plot that over time, what we find is the oldest fire pits, almost all of the charcoal is from native plants. Almost none of it is from Polynesian introductions. But over time, the influence or the contribution of the Polynesian introductions to the fire pits grows. Okay? So right around here is when we see the transformation of the landscape. Prior to 400 radiocarbon years ago, it's very unusual for a fire to have 10% introduced taxes, so it's 90% natives. After 400 years ago, it's very common to have most of the wood in the fire pit be from introduced species. So we think that what's happened is that this transported landscape, these Polynesian introductions, the plants that the Polynesians wanted to live with, had now taken over the environment of the lowlands in Waimanalo, and this transported landscape made Waimanalo look like a Polynesian place rather than a wild native Hawaiian place. Okay, this shows you the proportion of local firewood. One other thing that happened, it appears that what you see here is a slight rise in local firewood. Early on, people were bringing firewood to the plain, and these are mainly trees from the upland forests of Waimanalo, things that don't grow on the coast today. These are being brought down to the coast to make fires. And what we think is going on here is that the rats have taken out the native forest that was there and thinned it out considerably, so that firewood was an issue until the Polynesian introductions could replace what the rats had eaten. Okay, so we calibrate that boundary, and we end up at about 1450. So before 1450 AD, Waimanalo looked like a native forest, albeit one that had been affected by rats. After 1450, you have a place that looks like a Polynesian place with a landscape that looks like the homeland back in the Society Islands in the Marquesas. Okay, so that's the timing of the thing. What we see is the Polynesians got here later than we thought, earlier. They got here about 1,000 or 1,100. It took them a while to get established here. And then by 1450, even a place like Waimanalo was fully Polynesian. And so we're not really looking at a long period of time that Polynesians had to have an effect on the natural history here. Okay, it's not until 1450 that there are lots of people around really making a difference in the environment. So now we're going to look at the spatial side of this in a little bit more detail. The main one is the sweet potato. Okay, the sweet potato, unlike the other plants brought by Polynesians, which originated in Asia, the sweet potato came from South America. And it got into Polynesia because the Polynesians were terrific seafarers. They sailed all the way to the Americas, and they brought back sweet potato and also the ipu, the gourd, from South America, introduced it into Polynesia, and it finally made its way up here to Hawaii, probably around 1300 or a little bit before 1400 when we start to see the transported landscapes. It had a huge effect. The agricultural potential of Hawaii Island tripled when the sweet potato got here because it grows places that kalo won't grow. Okay, it tolerates soils that are, from a taro point of view, depleted in nutrients. It will grow places where you don't have a ton of water, or lots of flowing water, which kalo does better if you've got water flowing through it. So this rain-fed agriculture spread to large fields on the geologically young islands of Maui and Hawaii Island, and on the geologically older islands, they were grown on colluvial soils that had eroded off of the sides of the valley and were above the floodplain that could be easily irrigated for kalo. Usually when we think of Hawaiian agriculture, you think of the lo'ikawa, and they look like this. This is a picture I took in the 1970s in a little place called Manoa on Kauai. Most of these are mango trees, or many of them are mango trees. They blew down in Hurricane Eva or Iiniki, one of the two. I was last back here like 5 or 6 years ago, and it's all strawberry guava. You can barely see it in this. But basically, the lo'i go down. There's a stream right over here. Water comes off the stream, it gets fed in at the top, and it runs down through these, and it keeps the pond field agriculture going for kawa. Now, the northern islands, you can see this is the green is the irrigated agriculture, and the red is rain-fed agriculture. You can see the various areas of the islands that are suited for that kind of thing. Up in the north, in Kauai, it's all kawa. It's all irrigated agriculture. Here on Oahu, where we are, Manoa is a great lo'i. And you get a little bit of areas here that are good for rain-fed agriculture that you can't irrigate for kawa. But as you go south, what you find is on an island like Hawaii Island, it's just this North Kohala and Hamakua coast down in the gulches where you have conditions suited for kawa agriculture. And the main areas that were developed for agriculture are these dry land fields. This is the leeward Kohala field system, the Kona field system. Both of these have been investigated pretty thoroughly. And then one down in Ka'u that was mostly wiped out by Kohala sugar in the 19th century. Here on Maui, where the agricultural potential doubled, you see Tahiki Nui and other rain-fed agricultural fields. Now I'm going to look in some detail at the leeward Kohala field system because we've had most work done there. And what I want to impress you with is the how big it is, the 60 square kilometers, and how much work went into making this. But here we see really the extent of Polynesian influence on the natural environment, because we have a huge site that was completely transformed. But the other thing we have here is that with the intersections of the walls and the trails of this field system, we have a chance to date relatively what was going on. And so we can see the field system being built up over time and get some idea of how this expansion of the Hawaiian influence on the environment took place. Okay, the last part about this is that the field system production was intensified in the late 17th and 18th century to support large herds of pigs. Okay, we think now that the field system was not driven so much by hunger and need for food as it was for the desire to eat pork and have a good life. And this is something that archaeologists are arguing about now. There's a tribe of archaeologists who thinks that social change is driven by hunger and want, and another tribe, my tribe, the tribe I belong to, that believes that social change is driven more by people carrying out multi-generational projects to make things better. So this is the extent of the leeward Kohala field system here, mostly in what's now called North Kohala. North and South Kohala were divided up back in 100 or so years ago. It's a historic division, so it was all just one district, Kohala. And then I've labeled some of the ahupua'a here, Lapakahi, Kaihulena, Kahua 1 and 2, and these ones here, where most of the research has been done. So there's been some somewhat spotty research, but we do know that this was the former extent of the field system, and it's about 60 square kilometers. It looks like this. You can see here the coast, and this side here is upland, so you're running from the uplands, Mauka down Makai here. This part, which is slightly in shadow, is very dry. The bottom edge of the field system occurs where rainfall drops off to the point where sweet potato doesn't grow very well. And then the upper part of the field system, which is beyond this photograph, is determined by where there's too much rainfall. And the rainfall is so great that the water leaches nutrients out of the soil, down through the soil, where the sweet potato can't get them. Okay, so rain determines the upper and lower boundaries, Mauka and Mackay boundaries of the field system. Too little on the Mackay side, too much on the Mauka side. The field system itself, you can see the trails here, that line, another line here, this is a trail. Trails come all the way from the coastal villages down here, up about sometimes 3 to 4, maybe 5 miles down in the south, up into the field system. And then you can see, hopefully, see these walls going this way? These walls, we call them agricultural walls. They're about this high, about like this, and probably as wide as this stage here. And they're humped up like that. They're made of soil and rocks. And then the kind of thing that you would make if you had a garden rake, the rakes that are about like this wide and have tines like that, the hard tines. Not like a leaf rake, but a garden rake. Because you pull that through the soil and that pulls out little rocks and makes the soil better for growing root crops because you don't have rocks deforming them. But in the field system, what it does is it kind of corrugates it. Now, if you've been to Kohala, you probably know about Namakani o Kohala, the famous winds of Kohala. They roar through this place. They come out of the mountains and at a high rate. When we go out and we plane table map, we have a mapping board like this, and we're drawing on our maps. If you stand like this to the Makani o Kohala, bam, you can hurt yourself. I had one guy weighed about 120 pounds, and kind of a small guy. Lifted him right up and threw him. Okay, the wind just blew him, and he landed on his back and was kind of disoriented for a while because the winds are so strong. You have to stand on the side and let them slip by you. Now, for the sweet potato, what you need is you need something to break that wind, because the wind will just rip up the leaves of the sweet potato, and the tubers won't grow. You won't get good sweet potatoes. The Hawaiians did get good sweet potatoes. Cook's folks loved them. The Hawaiians gave them to the British for free. They just tossed them up, give them for free. Even the way the British put it, even the poorest natives would freely give us sweet potatoes. And they loved the sweet potatoes. The British loved the sweet potatoes because they hadn't had any that were that big in their whole lives. They were described as being the size of a man's head. Now, I never believed that until I went to the Kohala field system. Actually, this part of it here, there was a test plot here, and Ala Lindsay, who was growing sweet potatoes there at the time, told me about how he had brought his pigs down to clean the field, the pigs root, and they get all the old sweet potato out of it, and then they poop and fertilize the thing. He pulls out his cell phone. He's kind of like me. He's got not a smartphone, but one of these things. And he shows me a picture on it, this little picture of a sweet potato that he'd grown after he'd had his pigs down there. He was fattening up his pigs for his daughter's high school graduation. And to show me how big it was, in the picture it had his hat and his sunglasses on. So it was definitely the size of a man's head. Okay? So what these walls do is they break the force of the wind. They get turbulence in the wind so that at the ground level where the sweet potato is growing, it's actually not too windy. In fact, right at the ground level, there's hardly any wind at all. Okay? So these features allow the sweet potato to grow and make it very productive. This is a LiDAR image. This is Mauka here, and this is Mackay. You can see the trails coming up here, and these are the agricultural walls. Okay? Here's a scale here. This is 200 meters. So this is about one football field here, a little bit more than a football field, 100 meters. So we're looking at 6 or 8, maybe a kilometer on a side here. This is 1/60th of the field system. So you have a field system that represents 60 times this much modification to the environment to create the sweet potato fields. Okay, now very briefly to wrap this up, I want to give you some idea of how and when this developed. You can see this one on Google Earth. This is under the cattle pasture, this part of the ranch now. But you can see the trails here and then the walls under the pasture. Here in a drier part, you can see the bottom end of the field system. Nowadays, of course, people are building McMansions over there. This guy has to pay about $1,000 a month in water bills to make this green thing over here in the brown dirt. But you can see the field system up here. You can also see the cattle ranching down here, and this is, you can see the radial system of fields that they use. The cattle come out here, and then they come back down to here, and they close this gate, open this one up, and then the cattle come out in the next one. They kind of work around the clock that way in the cattle ranches. Okay, I'm going to skip over this because we're getting a little bit late, but basically we use something called graph theory that helps us map out the relative relations of the walls and the trails. And at two places here in Lapakahi and here down in Kohala, we can see the pattern of development. And this is from a map. This is an area, Lapakahi, how it looks on Google Earth today. And if we look at the early walls and trails, we find that they're built here. The second phase of wall building and trails fills in, it subdivides, intensifies the production, and then there's a bit in the third phase here. If we come back down to Kahua 2, here, oh, how did that happen? Oh well. Here you can see when the walls were built. We're starting in the 1600s or maybe late 1600s and running up through into the early historic period. Okay, pig production was increased in the early historic period because not only do people still want to eat pigs here, but you could trade them to Westerners who came in their ships. In the 1840s, Hawaii was a big exporter of pork to the gold rush in California. And most of the pigs that were exported came out of the field system. So you can see that this is a late development here. I knew I had Kahua 1 and 2. This is down in Kahua. You can see the walls and the trails. The map portion that we have shows that it built up like this. This would have been about 1600, 1650 maybe. Then over time, just before Cook got here, it probably looked like this. And then after Cook, it was divided up in this way, and production was further intensified. And that's all I got for you, unless you have some questions for me. Mahalo. Oh, question?
Yeah, what do you think the population of Hawaii was at the time of Cook?
That's a great question. Archaeologists have been interested in it, and they've speculated a lot, but they don't have a clue. I wrote something when I was younger about the population of Hawaii, and I really don't believe it now. I really don't. I've gone as far as to disown my earlier paper in print so that nobody would be too confused about it. But archaeologists don't have a way to measure it with any kind of precision that they've come up with yet. There's been an attempt to count how many rooms there are in houses, and then to multiply by a number of people per room, and then to date the house. But the dating so far of the houses hasn't taken care to date when the structure was built. And so they've messed up that database in a way that's irretrievable. And when we look at when the houses were built, what we find are the ones that we see on the surface now weren't built until the 1700s. So they're the last bit of houses. And so we don't have houses from the earlier times that we can count rooms in. So we cannot estimate population.